Hey YouTube, I'm going to go over using the AES or Randall managed, you could call it. I'm actually using AES in this. It's 256-bit encryption. Randall is kind of a prior thing, and the AES is considered a standard use. This program I'm about to show you will literally, I'm in my music folder right now on this, and it will literally encrypt every one of these files, and with 256-bit encryption, and you will not be able to open it. Nothing will happen. If you go through this, you notice I have some Microsoft Word docs, I have some regular text files, I have PDFs, I have a movie here, an MP4, and I have an image. Basically, what this program is going to do is it's going to go through the entire directory and this directory, and it's going to target it. I'm just going to go ahead and show you real quick how this works. I'm going to go ahead and hit start, and then 3 seconds later, it is going to encrypt that entire directory. I have it on a timer for this to go off in 3 seconds after the application starts up. That's how I have it set, basically. And as you can see, everything is completely encrypted. I can shut down this program now. If we were to try to look at one of these files, you're going to look at a bunch of gibberish shit, and you're not going to be able to read crap. That's how 256-bit encryption works. So this is what you're looking at. It's just a bunch of fucking shit you're never going to decipher. Not a billion computers at the technology we have today would be able to decipher this, just for the record. It is a nasty fucking program, and it is meant to attack the system. So we're going to go over this. And before we do, you need to know that committing, cyber crimes is a federal crime, attacking other people's computers. This program is meant to educate you so you know what to look for in case you ever come across bad code. This will seriously fuck up your computer. You won't have one if it goes through it. So as we're going, we start off with the global variables that are, calling a string for, the user's directory, and then we're calling the username under the environment. So we're getting that current user of whoever's using their computer at that time. We don't have to worry about who it is, their names, and all this other bullshit. For the record, I'm going to go and show you the form. I have 2 simple timers. I have one set at 5,000, which is 5 seconds. And this is what initiates when the program starts up. 5 seconds later, it encrypts. Both of these are true. If you go into timer 2, this is set at 20,000, which is 20 seconds. And basically, that falls into a self-destruct mode for this program, because normally you don't want your program traced back to you. So anyway, this also has a class added to it. I will actually show you that right now. If I go into my Solution Explorer, I have a class right here, and if you were to name this class, when you go to create one, you would basically go here, you'd go to add a class, and you would be adding this name right here to right here where this class 1 is. And then you would just hit add, and it would create a form, and you would add this code to it. Now, if we go back to form 1, you're going to see this name coming into form 1 load, which is right here. This is calling that. Now, what this does is it basically cuts your memory use in half, so your program isn't sucking up a bunch of RAM, and it makes it more stable or whatever. You go all over the internet and you see people trying to figure out how to do what I'm showing you right now, and they have difficulties in figuring out how the whole process works. Usually they have all they can do to just encrypt one file at a time. I've gone through and I've left some notes. You're going to see that I've created this and named all this myself. These are actually characters out of these names, Risengard, the Malevolent one. I actually wrote a role-playing system called Calder's Will, and if I were to go into Endorium, you will see that it's actually a thing. I created it, and I have some game coordinators that worked with me. There's a lot to this, but these are some gods basically. So I kind of applied all my language to my program to that. And I'm going to go ahead and go down through here. I've left some notes. It's using the AES, Raindahl managed 256-bit encryption. I've left little notes in the code that explain things. I explained the AES 256, which has a key length of 256 bits, supports the largest bit size and practically unbreakable by brute force based on current computer power, making it the strongest encryption standard. Now, when I say that, the NSA can't even crack this, okay? Not a billion computers in the world today at our technology can crack this encryption, and that is a fact. And as we get going, you're going to see that I've left some notes about block sizes and what they do. It's important that you understand this as you get going. But I'm going to go ahead and just keep going down. I want to make sure that you got all that. So this is a continuance right here of the encryption process that it goes through. And this is basically all those extensions you saw. If I were to pull this back up and go to music, you can see that every one of these have Rhythorian at the end of them now. And that's basically what this program does is it goes through and, takes that out. Now, you're probably asking, well, what happens if you go in and you try to rename this file? I'll show you what happens. Let's say I take this off, okay, and now we're back to a regular text. I go, yes, okay. I go to open it, and it's still encrypted because all the bit data is been mutilated. So that's how that encryption works. Doesn't matter if you rename your file back to what it was or not. And this is a moving process for the extension, which complements this. So right here, this is a collection of extensions that we are hunting for, okay, which is quite a few. There are a lot more. There are a lot more system ones as well, but I'm obviously not looking to encrypt my system. You are going to see as we get going that I have this blacked out because this is set to attack program files as well in program 86. Basically, if I were to, take this off, this is what we would be looking at. And this is basically an integer just going through, and it's continuing. So I'm going to go ahead and block this back out. And now that we have that done, we are moving into, this is a part where you can start calling all kinds of different directories. Now I have these blotted out, like if I were to turn this back on, and if I were to undo all of these, it would attack my entire system. It would attack desktop, downloads, documents, pictures, music, videos. It would be a mess. And then you have the upper half attacking everything else. So long story short, we don't want to do that because I like, this little shitty laptop I'm using right now. This is basically going through and getting all the logic drives, and I have this set right here which complements the music. So going down, this is a timer that we saw in the form, and it's basically, this is, when it stops, it's basically initiating the encryption. And this timer start, you're going to see, if I go back up to the top, you're going to see this inside my form. That's when the form loads, it's starting that timer. That's what's happening. And now we're down to here. I have this blotted out because I don't want my program to self-destruct. But this is the ultimate self-destruction. After 20 seconds of the program running, it will tell itself to self-destruct. It's basically going in through CMD and deleting its application executable path. And here at the form closing, if that event happens, it is doing a garbage collection, which reallocates RAM. And that basically covers it. I mean, this is a skeleton of how that works, and there's a lot of horrible things you can do, like process security, so you can't shut down the process, or blocking task manager and all these other fucking horrible atrocities. But I'm not looking to, you know, apply that code to this. I have to be smart about what I distribute for code online, and I just want you guys to be smart with it. I don't want you to. This is for educational research. It's not to be malicious. It is to, um, you know, make you more aware of malware and ransomware and how malicious programs like this operate. I've been programming. I do C#, I do VB.NET, I do Batch, HTML, CSS, JavaScript, and that about covers it. I don't know any other languages beyond that, but I'm pretty fluent in the ones that I've mentioned. I still need to work on JavaScript more, to be honest with you. But that wraps up Infernal Prophecy, which is the name of this program, and you guys have a good night.